So, in this slide, I will expand on the topic of redirection by showing you how you can redirect the output of your script to different locations on your Linux system. So let's begin with the understanding input and output. So far you have seen two methods for displaying the output from your script. The first one is displaying the output on the monitor screen. That's the one way. Second one is just redirect the output uh, to another file. So basically, it's like whatever output that you get from this command, we are redirecting that output to either another file. So we'll save that output of this command into that file so that you can use it. These are the two ways we are doing so far. So both methods produced an sorry, both methods produced an all or nothing approach to data output. So there are times, however, when it would be nice to display some data on the monitor and other data in a file. For these instances, it comes in handy to know how Linux handles input and output, so you can get your script uh, sorry, get your script output to the right place. So so let's begin with the standard file descriptors. So let's go through the points one by one. The first point in standard file descriptor is uh, the Linux system handles every object as a file. This is very important. I have been repeating this sentence as a broken tape recorder for almost uh, along this course. So every object in a Linux system is like file. So the Linux system handles every object as a file. So this includes the input and output process also. So Linux identifies each file object using a file descriptor. So this is very important point to be noted. Then the file descriptor is a non-negative integer, so that uniquely identifies open files in a session. So each process is allowed to have up to 9 open file descriptors at a time. So based on this logic, so the bash shell reserves the first three file descriptors, the 0, 1 and 2, for special purposes. Just note down these three digits, 0, 1 and 2. These three file descriptors has been designated for special purposes. What are those special purposes? We are going to look about these things in forward sessions. So these three special file descriptors handle the input and output from your script. So the shell uses them to direct the default input and output in the shell to the appropriate location, which by default usually your monitor. So this is the information about those three file descriptors that have been speaking about, that have been mentioning about. So file descriptor, the first one is 0. 0 means abbreviation is std in, simply we can say standard input. So for file descriptor 1, the abbreviation is std out, we call it as a standard output. Whereas the file descriptor 2, abbreviation is stdr, and the description is standard error. Just remember this three file descriptors. This is a very useful. Most of the scripts that we use in our real cases, we use these file descriptors heavily. We use these file descriptors. That's why please keep an eye and take these file descriptors into your brain directly and store it in your brain. This will come in a handy when you're working with your deployment. So let's begin with std in. uh, the std in the std in file descriptor references the standard input to the shell. For a terminal interface, the standard input is obviously and always it's a keyboard. If it is our laptop, it's a keyboard. It's a whatever keyboard that we have for a laptop. If it is a computer, we'll have a separate keyboard which can be connected through either USB, or you can also have a wireless keyboard. So that is our standard input. So the shell receives input from the keyboard on the std in a file descriptor and processes each character as you type it. So when you use the input redirect symbol, that symbol I'll show it, symbol. So Linux replaces the standard input file descriptor with the file referenced by the redirection. That's what the important points to be noted here. So it reads the file and retrieves data just as if it were typed on the keyboard. So that's the main point. And then many bash commands accept input from stdin, especially if no files are specified on the command line. So you can see an example on your screen, in this screen, using the cat command with the data entered from stdin. So here we have used a cat. So basically cat is to read a file. So when you use a cat, this is a test. Basically whatever that you type can directly display on the screen. So this is the best example to showcase your std in. So then what we are going to look into is std out. Mm, okay, before that we will look into this example. So when you enter the cat command on the command line itself, on the command line by itself, so it accepts the input from stdin. So as you enter each line, the cat command echoes the line to the display. So let me show it. That's fine. Let me clear the screen first. Cat, what do you want to type now? I'll type the same one. This is a std in test. This is a std in second test. Okay, you got it. Hence it's been proved. However, you can also use the std in redirect symbol to force the cat command to accept input from another file other than std in. So that's also we are going to do. So for that we will create a test file. Sorry, I'm in a wrong uh, yeah, I want to select this one. Yeah, let me clear this first. Okay, but I have to come out of the cat one. Yeah, so let me create a test file in test file. Okay, this is the I love Linux, I love bash, I love ubuntu, cat. Here it is. That's how it works. So basically we are redirecting uh, the input from test file to the cat. So now what cat will do? Cat will display. So basically std in. So here we use the std in redirect symbol. This is that std in a redirect symbol to force the cat command to accept input from another file, that is our test file, to uh, uh, basically display. And then so and finally what we have is std out. So the std out file descriptor references the standard output for the shell. So on a terminal interface, the standard output is basically the terminal monitor. So whatever that we see in front of our eyes, that's the standard output. So all output from the shell, including programs and scripts you run in the shell, is directed to the standard output, which is the monitor. So now in spite of that, we want to direct to somewhere else. So there, standard in is the standard input, that's through keyboard, whereas here standard out, the standard output is directed to the monitor. So most bash commands direct their output to the std out file descriptor by default. So you can change that using output direction. So let's take one example here. So let's do ls lrt, and we will redirect the output of this command to the std, just a minute, std out dot txt. So let me catch std out dot txt. That's it, that's it. In spite of normally the standard out, basically this symbol is standard out symbol and this symbol is standard in symbol. In this case, standard out symbol, in spite of directing to the monitor, it's directing into this file, whereas in this case, in spite of taking input from the keyboard, it's taking input from the test file and put it and giving it to this cat command. So that's how the redirection takes place. So now let's take one example. Let's clear this. Let's clear it, and then we will take one example. Of course we have done it, or else okay, but we'll execute one more time. The first example that we're gonna take is I'll write the name, it's Vim. Okay, first let me clear the screen first. So Vim, and it is the name I will give is again it's a redirection. So redirect 1.sh. Okay, bin and then bash. So output std out will directly std out standard out or standard out redirection. Basically the standard out symbol is the one which is redirecting. So now what I want to do is ls l in tmp, in lsl of tmp should be redirected to temp dir listing dot txt. And then finally, after that is done, after redirection is done, it has to read do the temp listing.txt. Just let's see. So chmod and then o plus x redirection.x, and then let me execute redirect.sh. Yes, that's it. So it's been redirected, the output has been redirected, and whatever files that are there inside that temp directory, all those files has been displayed on the screen, or displayed on the monitor. This is what we wanted to have. So the next we will move on to the next thing is, we will, once std out is done, so okay, we'll just continue with the std out. Few more points to be discussed here. So with the output redirection symbol, so that's std out redirection symbol, that's greater than symbol. All the output that normally would go to the monitor is instead redirected to the designated redirection file by the shell. So you can also append data to a file. So to do this, to append the data, you do this by using double greater than symbol. So basically this exercise that we have done in our previous slide, so if you give a one symbol, whatever the file, it will completely replace the data with the existing one. So but we want to append the data, whatever is there already should be appended. It should not be completely replaced. That's what we want to do. So for that we have to use another symbol. So that is our that's the symbol. So that's double greater than. So the output generated by the, for example, in this case, the following case, if you take this example, who and then greater than double greater than symbol and then test2. So in this case the output generated uh, by the who command is appended to the data already in the test2 file. So however, if you use the standard output redirection for your script, you can run into a problem. So you can look into this the following example just to handle that, to understand what is that issue. So but before we going into the problem that we are going to get from this, so first let us do one exercise in appending the standard out, the appending the output redirection, then we'll discuss about that problem. So here we will we'll create a new file, that's vim, and then file name is std out append.sh. So bin bash and then append the output redirection. I think mm, let me, I have to check the file that we have created. I think it's redirection. Just let me, sorry, escape wq. So ls lrg pipeline, and is it redirection? No, I'm not sure. Let me give ls. Where is that? It's a test file. No, temp listing. That's okay. It's a temp listing. So now let me get back to this. It's a temp listing. So I will use the same file because I just want to append. We before we have uh, we have uh, we have redirected, we have directed the output of the temp directory to this file. So now we will append that file with the who information. So who, and then that's a temp listing .txt, I guess. Then once it is done, do the echo. It's a decoration because so that it's clear. So the first activity is done. Then second activity is is happening. Then cat, it's a temp listing .txt. That's what I want to to be that's what I want to be displayed on the screen. So it's done. Let me execute it and see what's going to happen. So let me clear the screen first. It's uh, okay. Before that, let me change the mode o plus x, and then file name I have given std out, and then it's append.sh. Yes, it's done. Oh, std append.sh. Here it is. Okay, it got appended, but maybe the file name is wrong. So let me check it. There is something wrong. Std out.txt. What's the name that we have given? So it's temp list. Okay, okay, the name two. Okay, it's a text. It's txt. So these are two wrong. So we lost. We missed it. Okay, temp listing.txt. We'll add the file. It's not txt. It's the text. I'll add it. Yeah, it's actually txt. I've added text. So temp listing txt, I guess. Then this one, in spite of that, I'll add uptime. Yep, that's done. So this is the directory listing of temp, and this is uptime. So let me add one more to this. One more redirection. This time what I want to add, date. Date is fine. Temp listing dot txt. Then what else I can add? Yeah, I think this is enough. Yes, now you can see the date also. Yes, so I'll add one more. See, this got added two times because again it got appended. So let me add this time ls lrt of ls lrt of which one will put home. Okay, then append to temp listing dot txt. Yeah, here it is. So existing one, then two times date, two times, and one more time uptime, and finally the finally home directory. Finally the home directory. These are the users. I have test Surya Charan, Teja Charan, and Daksan. Okay, so the redirection part and appending the redirection part is also done. So now let's talk about the standard error. But before we go to the standard error, I would like you to discuss about one issue. So what is that? So let me check this up and bring it on right side of your screen, and let me clear the screen first. Let me write to LSL, and then I will give some random directory which doesn't exist only. Example, chavo, chavo. Okay, chavo is a random one, doesn't exist. Now I want to direct this to uh, test.txt. Okay, now let's see. So it's saying ls cannot access chavo, so no such file or directory. So basically what is this? This is an error. So now if you put this one, we'll create a vim error.sh bin bash, and then ls l chavo, and redirect to test.txt. Let's see. Let me close this. Okay, chmod, and the file name is error. It's error.sh. Let me clear the screen. Error.sh. So this is the output that you got, but let me check the test.txt, cat test.txt. Nothing is being stored in cat test.txt. So that is the issue. So let me go to the script again. Sorry, vim. Yeah, here I will add concatenation part cat test.txt. Okay, so whatever is there, yeah. Okay, so let me clear the screen. So once it is done, it has to whatever has been directed, output has been directed to the test.txt, that should display on the screen. That's the next command that I have mentioned. So let me execute. Nothing has been displayed, though I have put cat test.txt, because cat test.txt, it doesn't have anything. It's completely empty. There is no, nothing has been diverted. So only it is throwing an error. How to handle this problem? Because when you write a big huge number of a huge script which consists of 1,000 or 10,000 commands, 10,000 lines of commands, then how would you, where would you know, where would you get to know, how would you get to know that there is a file? To solve that issue, we have a standard error, std error. So by default, the std error file descriptor points to the same place as the std out file descriptor. Okay, but the main purpose of std the std is the shell handles error messages using special stdr file descriptor. So the stdr file descriptor references the standard error output for the shell. So this is the location where the shell sends error messages generated by the shell or programs and scripts running in the shell. So whatever error that has been generated, all will be sent to the stdr file descriptor. So that's the reason this is very important. So now by default, so this is where all the errors are pointed out. So this means that by default the all error messages go to the monitor display. That's it. through by default, stdr file descriptor points to the same place as the std out file descriptor. So that means whatever error that has been thrown out, all will be pointed to the std out, and std out ultimately point out to the monitor display. That's the reason you are able to see this error here. So that's the reason from stdr to std out to monitor. Okay, so now, however, as you saw in this example, when you redirect std out, this doesn't automatically redirect stdr. So when working with scripts, you will often want to change that behavior, especially if you are interested in logging error messages to your log files. So that is the reason the stdr file descriptor is set to the value 2. So this has a value, so we use that value 2. So 0 1 2, 0 1 2. So 2 is designated for stdr. So you can select to redirect only error messages by placing this file descriptor value immediately before the redirection symbol. The value must appear immediately before the redirection symbol, or it doesn't work. It has to be put before the redirection symbol, or else it doesn't work. So this is the example. So same example, if you want to redirect, so we'll take the same example. So before this output redirection symbol, the std out, you put the value of a standard error. So same file, we'll edit it. So here I will add 2, and let's see the magic, what's gonna happen. So ls cannot access chavo, no such file or a redirectory. So cat, that's it. That's it. It's been printed. It's been stored. It's been redirected to test.txt. So that's what I'm talking about. So let me clear the screen first, and then this time we will change it. So this time we will put append symbol, so that we can get to know how many times it's been pushing in. So cat, oh sorry, run it. So second time, again I'll run it third time. So because this is directly coming from the cat test.txt command, it's not just displaying the standard error output on the monitor. It's directly coming from the, see how many times, just run it, run it, run it, run it. It's been stored. It's been redirected all the time to the cat to the test.txt file. So that's how this one would be useful in basically redirecting the standard error. So redirecting errors and data. So if you want to redirect both errors and the normal outputs, you need to use two redirection symbols. You need to precede each with the appropriate file descriptor for the data you want to redirect, and then have them point to the appropriate output file for holding the data. So this is the example that you can see. So test the information from all this, and standard error, you want to put it in test 6, and then uh, while putting all those things, if you find if you get all the data that you want to put it in test 7. So here standard error you want to put it in test 6, and normal data you don't want to put, whereas from test 6, all the output from the test 6 you want to put it in test 7, the data. So 2 is for the standard error, 1 is for the data. So finally, if you check test 7, only the data is there, whereas in test 6 you can only find the standard errors. So let me get to the let me sorry yeah, let me get to the uh, my WSL and start writing a piece of code for this. And then it's redirecting test file, as well as both. We have to attach both. So let me clear the screen first. So vim, it's std error and std out. So std out and std error. So dot sh, sorry, dot sh. So I shabang and bin bash. So it's redirecting redirecting errors and data both together. So ls l, so test 2, test 3, and then bad test. So I do not know how many files we have in that. I think test 2 we do not have, test 3 we do not have, only test we have. I don't think I have that also, but still let's do that. Okay, then if there is a no, only errors should be pushed, if actual data should not be pushed. That's how that's what the redirection we have mentioned, that should be pushed to test 6. So now the test is the whatever data that is there in the test 6, that should be pushed into test 7. So that's one, that's the reason we have used one symbol and then test 7. Okay, so now let's sorry, let's add some decoration around the concatenation of the cat, displaying the displaying the uh, displaying the data from the files. So first we will read from test6 file, then echo, sorry, echo I hope you're liking my decoration. Then I really liked then cat test 7, then echo decorate again, but this time it's closing session, and then a line. So let's see what is going to happen. Chmod o plus x and std out error.sh, and then std out error.sh. Here it is, here it is. So all that it can save is no such file or directory exists, because so lsa lsl so test and test2, that's it now. So before that, let me create some sample files from, so okay, touch, sorry, touch and test 1 to 5, that's it. So ls l grep test. Yeah, so we have some tests here. So now let's go to the our file back, and then what I want to add here is lsal also. Okay, so now let me close it and let me run it and see. Okay, but this time in first file test6 you have only standard error has been stored, whereas in other file, in test in other file, that's a test7 file, in that the directories from the test6, from the initial one, has also been pushed. So this is how the number 1 and number 2 symbols helps us individually handling standard error and standard output. So then we will move on to redirecting the output in scripts also. So far we are doing that, but still, so you can use the standard out and standard R file descriptors in your scripts to produce output in multiple locations simply by redirecting the appropriate file descriptors. So there are two methods for redirecting output in the script. So one is temporarily redirecting each line, that is the one way, and the second one, very most important one, permanently redirecting all commands in the script. So for that, first let's look into the temporary redirection. So if you want to purposefully generate error messages in your script, you can redirect an individual output line to stdr. So you just need to use the output redirection symbol to redirect the output of the output to the stdr file descriptor. So when you redirect to a file descriptor, you must precede the file descriptor number with an ampersand. So that's what. So here you can take this example. So in this example, cat test it. So testing stdr messages echo. So we just want to purposefully push an standard error messages. These are not the standard error messages, but we want to create a error message and we want to purposefully push. If you want to push it in such a way, so this is how you have to write echo. This is an error message, and forwards sorry, greater than symbol, and you have to use ampersand and then 2. So echo, this is normal output. Okay, and this is actually normal output, but we are showing a way to push the we way to push it. So this, but this is a temporary redirection. This is not the actual redirection. If you run the script as normal, you don't notice any differences because this is a temporary one. So you have to use ampersand to basically redirect user defined standard error, user defined error. So remember that by default linux directs the standard error output to the std out. We know that. And std, however, if you redirect stdr when running the script, any text directed to stdr in the script is also redirected. So let's take an example at this moment related to this. And then, so vim, it's sorry, and then this is what the file I'm talking about. So bin bash as usual, so testing standard error message. So here this is a user defined error message. So what is that? This is an error. So output a redirection, and then I used ampersand, and then number 2 is number 2 basically considered as std error. So when it's std error, so then finally you said this is a normal output. This is actually not a standard error message, but a user defined error message. We are pushing it as a std error message. So let me give permission x and then 13.6 and then this. So let me clear the screen, and then 13.6. Yep, here it is. This is an error. It has been printed, and this is a normal output too. So as we have mentioned ampersand, so that's the reason it's been printed as error. So now permanent redirection. If you want to purposefully generate error messages in your script, you can redirect an individual output line to stdr. So you just need to use the output redirection symbol to redirect the output to the stdr file descriptor. So when you redirect to a file descriptor, you must precede the file descriptor number with an ampersand. The same logic applies here, but in a different way. So one, so we will take this example here. I'm talking about precede this with a number 2. So we'll take an example for this also. So let me clear the screen first, and then vim. This time it is 13.7. Yeah, this is the big example we have taken. So redirecting all outputs to a file. So, and these are all permanent. The first case is exec, is a command that we have used, and you can also redirect std out in the middle of the script, so echo. So this is only for test errors, and this is also for test error. So let me come down a bit, and so finally echo, but this should go to the test error file ampersand 2. Okay. mm, let's see what is going to happen with this command at the end, because we have mentioned ampersand here, ampersand 2, we are purposefully we are pretending that it's an error, but it's not actually an error. Okay, let's do it. Chmod o plus x 13.7 and then 13.7. Okay, so one line, the command not found. I think it's a redirecting that one only. So, and other than that, remaining stuff has been basically printed. So this